All right, and welcome everybody. First one of 2021. We did it, I guess. It's great to see you guys once again. As you know, my name is Felipe, creative director here at MakerBot, and yeah, super excited to get to start 2021 on the right note. Basically, that means one more episode of MakerBot Chats. We are really thrilled about the results that we've been getting with this, about your guys' questions, your guys' comments and feedback. We always wish we had more time to cover them up, but as I think that as this progresses, we'll try to address as many questions as many, issues, problems, or just general no knowledge gaps that you might have with 3D printing, and specifically with MakerBot printers. But again, really happy, really thankful for your guys' attention and continued streaming. And as always, more than open and happy to get more of those questions coming in and answering them. Now, last year we ended up on a difficult note in the sense that the last stream, for some reason, we had a lot of issues. So we're going to be doing a redo of that today, basically covering all of the new materials. Let me show you guys what that means. But basically what I want to do today is, here I got my handy MakerBot website. But what we're going to be doing today is basically covering most of these materials, talking a little bit about what they do, what they are. Now the material list of Method has grown considerably. We are at 24 materials. Like these are actual tested, tried materials that we actually advertise, right? So, and on top of that, there's the MakerBot LABS that allows you to print any other material as long as it's 1.75 millimeters in diameter. So the platform has grown considerably, right? And because of that, we wanted to do a quick overview of what those materials are, what can you use them for, what can you expect them or expect from them, and specifically talking a little bit about these last three materials, right? So the ones that we introduced right after or before the year ended: ABS Kevlar, ABS ESD, ABS electrically conductive, and ABS carbon fiber. Those four coming from Kimia, our French partner, materials partner. I'm sure you guys have heard about those materials. So we're really happy to have them on board. And yeah, essentially that's what today is going to be about. I'll do a quick overview of those. Let me start by, let's see. Well, the one thing that I'm not sure that I'm getting right. Well, yeah, this should work. I think I'll do just, we did a quick webinar going on, how does this material test, which ones are stronger. So if you have any specific questions about these materials, the technical performance, do send them out. You will see that comment box on the right-hand side of your YouTube window. And also, by the way, Alejandra, our mastermind in chief behind the scenes, will be gathering all of those questions and we will be answering them as we go. So let's get started, and I just want to make sure that you guys will see my full screen. I assume that that's the case. So material showdown, as I was saying, we now have 24 materials for Method. It depends on whether you have a Method X or a regular Method. The materials that you will be able to print with the Method Carbon Fiber Edition, it comes basically set up to start printing nylon carbon fiber, both nylon and nylon 12. But essentially, if you have the Method X, you get access to all of these 24 materials. And then also, sorry about that, through the Labs extruder, you get an additional set of materials that you can print with. Specifically, we've introduced ABS Kevlar, ESD, and electrically conductive, and carbon fiber. We'll talk about those a little bit today. ABS ESD, great for insulating electronics. If you think about, it basically stands for ABS electrostatic discharge. It allows you to have a better way of managing, the static electricity that you might be having in your hands, in your body, when interacting with these sensitive projects, I guess, or electronics. In this case, I designed a Raspberry Pi case. That's my Raspberry Pi right there. I'll have it here and I'll show you guys in a second how does that look like? But it's essentially allowing you to better insulate your electronics, and Kemia ABS ESE allows you to do that, and it actually provides a great material finish. Let me see. I think I can jump right into the. Here we go. To my webcam. I apologize for the glare, but it's rather sunny right here. But if you can see now, like the finish of the part. It's actually really nice. It's got this like matte finish, but both the roof and the floors are super, here we go, are super smooth, super nice and tidy, right? All of the little details came across great as well. So this is a really nice material to work with. I mean, it's essentially ABS, right? But it does have that matte quality that I really like. And as I was saying, like great for insulating electronics, as I have the Raspberry Pi still nested here, just a few little details to hold it in place. This is part of an assembly that I was working on for my robotic gripper. It's not done yet. I'm hoping to finish it up in the next couple of weeks. But essentially, this is a controller that I'll be using to run my gripper later on. Now, going back to the material list, we've also introduced ABS electrically conductive. So this is, now think about it not as a metal, right? It is conductive, but it's more, it allows for a better flow of current. Now, it's not an insulator. It's not longer a plastic, but based on my experience, I wouldn't call it, fully conductive material either. It definitely has much lower resistance, but you'll have to test it out, right? It's not immediately, a metal that you can just connect wire A to wire B and then have a current flow through it. It definitely has a better flow, or as I was saying, like smaller resistivity than just ABS, so it's not insulating anymore. But if you're trying something like this little electronic cap that needs to have a small current flow through it, you think about some of the capacitive touch sensors, I think that could also work well with it. But again, don't expect like a full-on metallic performance. It's not that, but it definitely has better conductivity than just ABS, which is essentially an insulator. ABS Kevlar, and for this one we actually did a really nice. We have a video from Kemia actually, right, testing this one of the parts. I don't have it here. Actually, I think I left it on the outside of the room, but essentially. Kevlar is a great material for, not for tensile stresses, but rather for punching on it, right? For compressions on it. If you think about it, it's essentially the exact same material that it's used on bulletproof vests. So really strong material, really lightweight as well, and super easy to print with. I really enjoy printing that one out. This jig that Kemia made, it's just a punching jig. So they have the press jig. They position the metallic plate, and then they perforate it with it, and the jig holds in place said metallic part. So really, really nice material to work with. Super strong, super lightweight. If I was to compare it, Kevlar versus carbon fiber, which I get that question a lot, what's the difference between both of them? I would say nylon carbon fiber, it's much better for tensile stresses. Kevlar, it's great for compression loads, right? Anything that's going to be under, just like this press jig is showing. So depends on your application. I really, really enjoy, but that's my personal bias. I really enjoy nylon carbon fiber, but Kevlar definitely is a great alternative to have there for some of the projects that you might be tackling. Now, we did a few tests, and I'm not going to take you through all of them because we don't have that much time today, but if you want to learn more about the tensile strength of these materials, how do they compare? We actually run them, and I'm going to run these videos. They are all slow-mo videos. You'll hear some of the sound of it, but essentially we've been printing these, what we call S-hooks, and putting them to the test in this Mark 10 force gauge, right? It basically pulls apart, and we are able to capture, what was the maximum load that this specific sample was able to withstand. In this case, I'm testing ABS. The peak is like 130 newtons. So this is also measuring in newtons, and you'll see how it fails in just a second, right? You see how the little sample just pops out of it. And we conducted quite a few of these. We actually been doing this for a while now. I have all of the results. I'll just run straight into the results because I want to talk about that. I mean, we've been doing all of the materials, right? And the plan for me at least is to have all of the materials available so that you guys can see it. This is more of a way for us to show like a more transparent view, right, of the results that we are getting. I mean, this is not super rigorous or strict, but it definitely gives us a good baseline and understanding of how these materials are performing, right? So what we did is we took three different samples of each material. So carbon fiber, polycarbonate PBT, polylite, also from Polymaker, our nylon material, ABS. We printed 3 different samples in most cases, right? Here in the PC, we only ran 2 of them, and we just tested them out. So how much load would they take? And 2 things were really important for me. First off, we wanted those samples to have a consistent result. So this is kind of a weird outlier. The fact that the maximum load is kept consistent is important because that also shows that A, the material is consistent, B, the printing process is consistent, and the results ultimately will yield constant outcomes. Now, with this carbon fiber sample, one of the things that happens is that carbon fiber, well, specifically nylon carbon fiber, can be very sensitive to humidity. So my guess is that that part had been out of the printer for quite a bit of time. Maybe that was why that blip happened. But overall, you'll see how these parts perform fairly consistent, and ultimately we wanted to look at the averages and see which was the strongest material, right? And in this case, hands down, nylon 12 carbon fiber, amazing material to print with. I love the finish, I love the strength of it. That's what I use to print my gripper. I'm still building it, as I said before. This is going to be quite a large assembly, I hope, in the near future. But yeah, super happy with it. And from there on, you'll see all of the other materials tapering in, PC, ABS, PLA. Sometimes I hear the questions, coming to me and saying, well, what's the best material and which material should I use? And the real answer is that it really depends on your application. So even though, for instance, nylon 12 carbon fiber might be the strongest one, if you're looking to do an outdoors a part that needs to be exposed to UV light or rain or just the elements, you would be much better off with PC or even PC PBT, just because that material is better suited to be exposed to the elements. It's better suited to be exposed to UV light, in some cases even to some levels of humidity. That's where also maybe nylon or PTG might come in handy. So it all depends on your specific applications. But all in all, as I said, 24 materials, super excited. It's been a while for MakerBot, I know that. I think that MakerBot has evolved a ton through the last couple of years, and we're really excited and proud about that. When we first launched Method about 2 years ago now, we only had 3 materials available for it, but now we have 24, out of which 4 of them are just your standard polymers, right? Your sort of grunt work, basic polymers, PLA, TOF, nylon, PTG, the basic stuff that you'll always want to have available. Then 4, sorry, not metals, there's a typo in there, and I do need to correct that. Because well, I don't know. Not going to comment on that. But in any case, 4 like more performance polymers, ASA, ABS, PC, and PCFR. 2 composites, nylon carbon fiber, nylon 12 carbon fiber having a much stronger tensile strength, however being much more sensitive to humidity. Nylon 12, a much more stable material, my favorite of the year by far. Really happy with it. Incredible finish, super easy to print with, really strong, super stable. Can't say enough good things about it. I'm really excited to work with it. Then 12 partner polymers, right? So these are the labs materials that we've actually integrated to the platform. 2 of them coming from Jabil, 4 from Kimia, the ones that I was describing before. Polymaker also with 2, and also Mitsubishi Chemical with 2 more materials, one of which, this Jabil material, the SEBS material, super exciting material, flexible material. So there's a wide range of choices. And within labs, also the fact that you can use these materials, well, not only those 12 sort of certified materials, but just use any material as long as it's 1.75 millimeters in diameter in the spool. and you'll be ready to go, right? That's the whole promise of labs. That's the whole promise of the Method platform. The idea that you can actually expand it and make it your own. And finally, the soluble support materials, PVA, which is kind of like a more common material overall, and SR30, which is, Stratasys's support material. Amazing stuff to work with, specifically better suited or much better suited for these high temperature or more advanced polymers such as ASA and ABS. You cannot print PVA with ABS, you cannot print PVA with ASA. SR30, however, it's such a beauty to work with because, or not beauty, but like so much fun to work with because it gives you all of that real flexibility while keeping the door open for more technical materials, right? For the more advanced materials. So really happy with SR30. It does, it's soluble. It does require a few more steps. You do need a wash tank, but if you have the space, the equipment, and are able to use it, a great material to use specifically or especially if you're trying to print real complex parts with more advanced thermoplastics. And with that, I want to start going towards, oh, yeah, this is correct. I'll just do a few, a quick overview here of some of the samples that I have with me. And in the meantime, I'll also start collecting those questions from Alejandra. As I said, send them out and we'll be answering as many as we can right now. But for now, I was talking about the CEPS material. So flexible, this one already broke because I've been using it for so long. But I would say, this part probably took about 50 to 100 cycles. It depends on the geometry, right? So the geometry will definitely affect the performance. This is a CEPS material. This is one of the labs material, but the flexibility of it. I know that many of you might be more familiar with TPUs. In my experience, TPUs tend to be more trickier to print with, but CEPS, it's way more stable. It actually comes in two colors, white and black. So at least you have some choice there, but really, really stable material, super nice to print with. I've been using it without any infill, just to be sure to get like the right amount of flexibility from it. Because as soon as you start putting infill on it, as soon as your walls become more than 2 millimeters, you will start getting, more or stiffer parts, which you might want. But, the ultimate promise of CEPS is just to be able to have these kind of very flexible elements available. So really exciting material, leaving it here. We talked about ESD, super nice material. I really like the finish of it. I'm not going to be covering the 24 materials today, but I just have a sample of them. This guy, Kevlar, really, really, really nice material. And this is, okay, I was talking about the supports, right? So this is the final part. This is part of a gripper. Where am I? Here we go. This is part of a gripper that Kimia developed. And essentially, there is no way to print it without supports, right? No matter my orientation, I will always need supports. You could maybe get away without getting or using supports in these holes because they are small enough. However, just to make sure that you get your consistent parts, you get the actual right dimensions, you will want to use supports, and this is how it actually prints out of the machine, right? And this is one of the materials because, the substrate or the main component is ABS. It will work really well with SR30. SR30 supports this white material right here, and essentially you just dunk it in the water, in water and the wash tank with the solution, and you get a proper clean part. But look at the finish of it. That's one of the things that impressed me the most, like just the sheer print quality of that roof and the floors. Let me see if I can focus. There we go. You see almost, or I don't know if you guys can see that, but there's almost like cloth quality to it, or let's see if the camera will focus on it. Come on, you can do it. A little bit further out. There we go. So if you look at the finish of the roof, right? Even the stitching of the last layers, it's just so dang sharp. So really excited with this material, super nice, really easy to print with. Again, ABS Kevlar. So more options for you to choose from, which is always great. Personally, my favorite, as I said before, and I said it a million times, and I'll keep saying it, has to be carbon fiber. But yeah, overall, really excited about the results that we've been getting. So with that, I'm going to open the floor to some questions for the last couple of minutes, and again, keep sending them out. These all works because of you. We are always happy to be answering these questions, as many of them as you can have. I know that sometimes we don't cover all of them, but we try. We definitely try to do as many of them as possible. Let's see, what should we use as the background? I think one would be like just the overview of the materials. So if you go to makerbot.com and then toggle to the materials page, here we go, you'll be able to see all of them and get a more detailed description of them. But in the meantime, what plastic is used to make current Beyblades and can it be 3D printed? Okay, so Beyblades, I didn't know like they were still around, but my guess is that that would be ABS. That's the most common thermoplastic, and it's the one of the most common injection molding plastics. ABS, definitely you can use it with a method, and it can be 3D printed. As I was saying, it's one of the sort of more advanced polymers. You can print it with the method X. You will need, sorry, you will need the heated chamber, right? Because ABS does have quite a bit of sensitivity to thermal changes. So as you're printing it, it will want to contract. Having a heated chamber in method is what allows us to print ABS so successfully. But yeah, straight answer, Beyblades most likely are printed with are injection molded with ABS, and you can use ABS on the MakerBot Method X. Is there any material we can use to print, such as to print metal? I'll keep that question open, but yeah. So right now we don't offer any metal materials. It's definitely something interesting. However, with carbon fiber, that's one great replacement for metal parts, specifically because it's going to be much more lightweight and it will have a great stiffness and tensile strength to it. So I would definitely recommend looking into carbon fiber if you want to print something similar to metal. What's the difference between Kevlar and carbon fiber? In my experience, the main difference would be the tensile strength, right? Carbon fiber is a little bit more flexible. Kevlar has, it's much better suited, as I was saying, for impact stresses, for compression loads, and carbon fiber will do better with tension loads. That's what I've seen so far, and it also seems to be reflected on the technical specs. I really like the flexibility of the carbon fiber. As I said, it's just a really nice material to work with. Kevlar, it's much more specialized. It all depends on the application. If you're looking for something that will withstand compression loads, maybe you'll be better with Kevlar. For more general, high strength, low weight parts, carbon fiber would be a better option. PETG or ABS stronger? Let me see, is PETG or ABS stronger? I believe, let's see, do I have it, the results here? I don't have PETG here, but so if I'm not mistaken, because we actually tested it out, the answer is that ABS will be stronger, but PETG is better suited for outdoor applications, right? And also especially for applications that will be in contact with solvents or water, PETG will be better. So it depends on the application. Overall, ABS might be stronger. For some specific applications that will be exposed to the elements, PETG might be a better fit. Are solvents adequate for dissolving PETG residue? I'm not sure what you mean by residue. So I think I will need to elaborate that part, because when 3D printing PETG, there's no residue after the printing process is completed, so I'm not sure what the question here is. Is Kevlar chemically resistant? That's a good question. I'm not sure about that. I'm sorry that I'm getting a lot of unknowns here. But overall, if you want something chemically resistant, I would say it's better to print with either PETG or the polycarbonates as opposed to Kevlar. How do I choose the right filament for my application? It's a hard question, right? It all depends. Are you trying to print something sturdy or flexible, something that will need to withstand a lot of cycles? For example, if you're thinking about gears, if you're thinking about parts that will have these repetitive actions applied to them, then nylon would be better. Are you looking to replace metals? If you're with something more lightweight but as strong, maybe then carbon fiber. Are you looking to print something that will withstand the elements? ASA, PETG, even nylon can work for that. So it all depends. There are many parts to the question of, how do I choose the right filament for my application? How do carbon fiber and PLA compare in terms of oozing? That's a great question. And I would say that carbon fiber, if you're using the right settings, it oozes in a different way, but you're not going to get the stringy parts that sometimes you get with PLA. So I think that overall, PLA is a better control material, but carbon fiber will yield better mechanical results. Maybe that's a good way to answer that question. What are some flexible materials you can print on a method? Well, that's precisely the SEPs, right? I was showing you the SEPs. I have used in the past also TPU, also really interesting, but my favorite for flexible is SEPs, SEBS. If you go to our materials page, it's right here. It's actually the same parts under labs. This is actually supplied by Jabil, but I'm really happy with that material. Super exciting. But yeah, SEPs, TPU, I've used as well. My favorite is just SEPs. Does PLA need a cooling fan? Yeah, you do need a cooling fan to print PLA, and actually the cooling fan is embedded on the method on the extruder itself. So as the printing process is completed, then you'll see the fan cooling down your part. So yeah, and I think that pretty much sums most of the questions. So I'm going to cap it there, but if you have any more questions, do make sure to reach out to either hello@makerbot.com, also Felipe, F-E-L-I-P-E, @makerbot.com. We'll be more than happy to answer those questions, and as always, we'll see you next week. Again, really excited to see you guys once again in 2021. I'm really hoping that things are going well for all of you guys, and hopefully we'll get through the next months, years, in the future together. I'm sure that there's a lot of exciting projects coming along, and we're really happy to be part of that. So do keep sending us our questions. Do keep letting us know what works better and what would you like to know more about. But in the meantime, again, thank you guys so much for a full year almost. Well, by March, it'll be a full year, but about 9 months, let's say. So a full baby worth of conversations here at MakerBot Chats. Really happy, really excited about the results, and hopefully you guys are too. Hopefully you're finding this interesting, and reach out. We are always happy to hear from you guys. So thanks again, and we'll see you again next week. Have a good one. Bye.